All right, this is Mr. Smith, Dog, here for Algebra 2, Section 13.2. The goal of this section is to teach this other measurement, angle measurement system called radians. To teach radians. And so the idea is we have two systems, for instance, to measure temperature, Celsius and Fahrenheit. And the same way we have two systems to measure angles, and it's called degrees, which we're all very familiar with, and radians, which I will show you today. Before we get there, though, we have to introduce our basic standard position for angles. And so we use our coordinate plane, and we put the vertex of the angle on the origin. We say that the initial side comes out off of the x-axis in a positive direction, and then our angle rotates through counterclockwise. And this is our standard notion of an angle. So if I wanted to talk about a 30-degree angle, I could draw our coordinate plane, put the vertex on the origin. This would be our initial side, and now a 30-degree angle will look like this and come out, and that's our terminal side. This is called the terminal side, and here we have what is a 30-degree angle. Okay, and so we're just going to use this as our construct for talking about angles, and this will become second nature. We're going to do this over and over again. Okay, so nothing to be worried about, no quiz questions here. We're just going to keep doing this. So, if I want to talk about an angle measurement that is 240 degrees. Okay. So again, I have my initial side here. I have my vertex there. And now we want to talk 240 degrees. So if I go up to this line, that's 90. Right? If I come down to this guy, it's 180. All the way down here is 270, so it shouldn't go quite that far. So maybe something like this. And this is 240 degrees. Okay. Right, so again, our initial side comes here, and we bring it all the way around, and that's our terminal side. So that's our standard idea of how to do an angle. All right, so let's jump to angle C. And so here's our initial side, and now we want to talk about negative 50 degrees. Negative 50 degrees. So instead of rotating in a counterclockwise method like we would in the standard procedure, we're going to rotate clockwise, and we're going to come down, let's say 50 degrees, and there's our angle. Okay, so all we're doing is making an angle. You don't need a protractor for my class. You just simply need to ballpark it roughly what we're looking for. Okay, so the idea here is that a negative 50 rotates down this direction, a positive 50, if we were to be asked to graph a angle that was positive 50 degrees, it would come up and be like this. Okay. And so again, we're just putting angles onto the coordinate plane, and we're starting with an initial side, and we have any positive rotation will always come this direction, any negative rotation will come this way. So now let's talk about 500 degrees. All right, so where would an angle, if I draw it, of 500 degrees be? So we know that if I come all the way and do a full circle, how many degrees is that? 360. Okay, so I need to keep going then if I want to get an angle of 500 degrees. And so if I keep coming, let's see, 360, I need to go another 140 degrees, right? So if I come up here, that's 90 more, and now I need to go 50 more than that. So this angle measurement, roughly, is 500 degrees. Okay? And it's the same angle measurement as if I went 140 degrees. So we can talk about any big angle, and we can take out of it multiples of 360, right? Because the 360, anything bigger than 360 is more than one revolution, more than one rotation around. And so we could talk about an angle that is 12,000 degrees. Okay. So the idea that an angle measurement could be 140 degrees or could be 500 degrees, but they still point point the same way. This idea is called coterminal angles. And what we mean there is that they essentially are the same angle. Right? There is no difference. If I drew an angle that was 140 degrees or I drew an angle that was 500 degrees, there is no difference. You wouldn't be able to tell the difference unless I told you that I was drawing an angle that was 500 degrees. And so we term this coterminal. All right, and so we're going to take a look at a couple examples of coterminal angles on the next slide, just like 500 and 140 were on the previous slide. Okay, so here they give us two angles, negative 45 degrees and 395 degrees. And so we want to talk about negative 45 degrees. Let's start with that one first. And so the idea is that our initial side is there. And now it's a negative degree, so I'll rotate downwards. I'll rotate clockwise. And now I'll rotate clockwise 45 degrees, which is roughly there. So this is our angle that's negative 45 degrees. Okay. But how could I, instead of thinking about it as negative 45, how could I think of it in a positive direction? Right? So don't think about going this way. What if I went the other way? This angle would be the same as 315 degrees. And the reason is because 315 degrees here and 45 degrees there gets me to 360. Okay. Over here, this is 395 degrees. Let's go ahead and graph that. So here I have this guy, and 395 degrees. 360 is all the way around once. And so this would be our angle that's 395 degrees, and that's the same as 35 degrees. Okay, we could subtract out 360, right? Because 360 degrees is just a full circle, so it accomplishes nothing. So 360 is gone, and we're left with 35. So 35 degrees and 395 degrees are coterminal. It just means they point the exact same way, even though they're two different numbers. Okay. Let's talk about this problem, though. This is 35 degrees, right? But what if I were to think about this going in the other direction? So this would be negative what? How could I talk about this angle as a negative angle? Okay, so negative 35 is a good idea, but negative 35 gets us down here, right? So when we think about the way the negative works, negative 35 is only going to take us down here, so it's not going to get us all the way back around. So if we want to go all the way around this direction, we talk about that angle as negative 325. And all three of these angles measure the exact same outcome. They all get you the same direction, namely this way. Okay? And that is the idea of coterminal angles. So this is the real emphasis of the section, is the introduction of this new numbering system. Okay? And it's called a radian. And here's the basic idea, and that is if you take the length of the radius and you're to travel that along the circumference or along the circle itself, you'll get 1 radian. Okay, so this distance here, which is the length of a radius, is called 1 radian. Okay, and that's what's going to be the basis of our new measuring system. All right, so the old measuring system, don't freak out yet. The old measuring system said we're going to have 360 degrees in a circle. Now, who picked that? Why aren't there 400 degrees in a circle? Why aren't there 10 degrees in a circle or 100 degrees in a circle? Okay, and so somebody chose this number 360, and in the same way, somebody chose this measurement system that said, look, take this radius here, whatever the radius is, and we'll travel that along the circle itself, and we'll keep filling the circle in with radians. Okay, and so we can keep going all the way around. And so here's the idea, and I won't get into the math of it, but basically there are 2 pi radians in a full circle. Okay, so in the same way that if I have my circle here, and I want to talk to you in degrees, okay, if I want to talk to you in degrees, how many degrees is it all the way around the circle? 360. We're very comfortable with that. And over here, if I want to go all the way around the circle in radians, how many radians is that? It is 2 pi. Okay, so let's talk about half a circle. Over here, how many degrees is that? Okay, so half of a circle should be 180 degrees. And half of 2 pi, if I want to go half of the circle, so this will be pi radians. 1 pi, right? But we don't put the 1, right? But this is 1 pi radians. Okay. Let's talk about a fourth of a circle. How many degrees? 90 degrees. Okay. Let's slow down a little. Coming over here for radians. Okay, so this is between 0 and pi, and so half of that distance would be half of pi. And we write it as pi divided by 2 radians. So this is, all we're doing is making equivalence relationships between radians and degrees. In the same way that 0 degrees Celsius is 32 degrees Fahrenheit. Right? That's an equivalence. That's all we're doing here. We're creating an equivalent relationship between radians and degrees. All right, let's talk about 3/4 of a circle. How many degrees? It should be 270 degrees. And now when we come over and talk about radians, how many radians will that be? 3/4 pi. Careful, 3/4 pi is up here. This is 3/4 pi. This down here should be not 4/3. It should be 1.5 pi. Right? This is between pi and 2 pi. So this is going to be 1.5 pi. It's what you meant when you said 3/4 pi. But this is actually going to be 3/2 pi, or 3 pi over 2. Right? Because 3 over 2 is 1.5, and then the pi is our reference back to radians. Okay. Let's do one more here. Just try to help you guys see what's going on. So if I split this angle right here, right down the middle, this is going to be how many degrees? Between 0 and 90? This should be 45 degrees. And over here, how many radians? It's going to be not 1/8 pi. It should be 1/4. So this should be pi over 4. Although if you take 45 degrees and break that into half, and we get right down the middle, 22.5 degrees is going to be 1/8 pi, or pi over 8. Okay, now that's a value. That's a value that you're not going to see very often. We're not going to work on that. But I want you to get a sense for how this works. Okay? And so what we need is we need a conversion. And you've actually already developed it. You've already developed it in your mind intuitively. But here are our conversion factors. Okay, so if I want to go from degrees to radians, I multiply by pi radians over 180. If I want to go from radians to degrees, I multiply by 180 over pi. And this is how we're going to convert back and forth. Okay. And where do these numbers come from? Well, this is just, we already knew that. Pi radians is 180 degrees. 180 degrees is pi radians. This is just a conversion fact. It's nothing to get worked up about where these numbers come from. Okay. And so we're going to use this knowledge now to convert some non-standard angles. Taking a look on the next slide, here we want to convert 315 degrees to radians, and then they gave us pi over 6 radians, and we want to convert that to degrees. Okay, so 315 degrees, we're going to multiply this by pi over 6. Sorry, not pi over 6. I apologize. It's going to multiply by pi over 180. That's our conversion factor. And now you never want to convert pi to 3.14. You always want to leave pi in here. Okay, remember, we're talking about radians. We want to see the pi. So we just want to write this as 315 pi over 180. And now the question is, can I simplify 315 over 180? The answer is yes. And so it ultimately, if you use your calculator, you can do this a little bit more quickly. Don't worry about the pi. Just simplify 315 over 180, and that will get us 7 pi over 4. And the reason is because 315 over 180 simplifies to 7 over 4. Okay, so we just simplify the fraction, the number piece, leave the pi in there. Okay, this helps us to see that this is a measurement in radians. We don't want to see this as a decimal. That will really hinder our progress. Okay? Here, if we want to talk about pi over 6, and that's in radians and I want to convert it to degrees, I simply multiply by 180 over pi. The pi should cancel out, and this should be equal to 180 over 6, which is 30. And so what that tells us is pi over 6 radians is 30 degrees. Okay, pi over 6 radians is 30 degrees. And so to put all of the pieces kind of together for you, I think this slide, I realize at first looks very confusing. But it tells you exactly the conversion. So here's 30 degrees. How many radians is it? Pi over 6. Here's 90 degrees. We looked at that earlier. That's pi over 2. Here's our 45 degrees. That's pi over 4. Okay? And really, I'm going to ask you to memorize this, but it's not as bad as it seems because, number one, we have a conversion factor that if you know the conversion factors, you're all right. And number two, all you really have to do is memorize the first quadrant, and now you can use these values to find all of the other ones. Okay, because, for instance, if I go 90 degrees, that's pi over 2. If I go 90 more degrees, that's pi over 2 plus pi over 2, which is just pi. Right? Or if I go 30 degrees here, that's pi over 6. If I go 120 degrees, that's pi over 6 plus pi over 2, which is 2 pi over 3. Okay, so we can use our knowledge of the first quadrant to help us fill out the entire circle. And these are the values that we're going to use. Notice 30, 45, 60, and 90. These are the most important values that you're going to use. Okay, so we will spend some time. First of all, as you get more exposure here, this will come pretty naturally. And second of all, I am going to ask you at one point to memorize this, and I'll give you the degrees, and you'll have to fill in the radians, or I'll give you the radians, and you'll have to fill in the degrees. Okay. So at this point, this concludes this section, this half of this section. I'll teach the second half in the next video. There is a homework assignment, but it's not for this part. It's a homework assignment for the whole thing, for the whole section, and I would encourage all my students to take a look at that homework before I teach the second section. Okay. Thanks for your attention. This is Mr. Smith signing off.